Hey everyone, my name's Eric. I'm an engineer focused on hardware and software for connected devices. I've been exploring LTE connected projects recently, and today I'm going to talk about the honey cabinet that I built. I'll give a little context. So recently a family friend got into beekeeping and as a result had a bunch of leftover honey. So we're kind of brainstorming what to do with the leftover honey and decided on kind of a little free library style cabinet where the cabinet would be full of jars of honey. Users could scan a QR code, they can make a payment for a jar of honey, and once the payment confirms, the door can unlock and maybe install this in in their front yard or like on a neighborhood corner or something like that. So the hope would be that you'd have totally hands-off selling. You wouldn't have to keep cash out in the open. You wouldn't have to rely on the honor system for people to just choose what they purchased or provide cash or anything like that. So let's talk about this enclosure that we designed. I opted to design my own cabinet rather than trying to purchase something off the shelf to try to keep the costs as low as possible. I really wanted to be able to have everything cut out of a single 2 foot by 4 foot sheet of plywood. In this case, it's 1/2 inch. And I modeled everything in CAD before making any cuts because I'm very much a computer person and less so a woodworker. And here's kind of what I ended up with. We've got the door here with a cutout for clear plexiglass or some kind of see-through material so you can see what's in the cabinet itself. We've got a slanted roof to shed any weather or rain or anything like that. There's a shackle and lock system, which is going to control access to the enclosure. And then I've got some 3D printed, intended to be 3D printed drill guides to make sure everything lines up correctly. So here's how it turned out. So next, let's talk about how we're going to manage the inventory. One of the design goals was the ability to see how many units are left in the cabinet remotely. So I explored a couple of different ways to do this, and between cameras or some switch mechanism or something like that, and I settled on load cells. And the idea being you would calibrate the system based on the weight of one unit, and the firmware could calculate how many units are left in the enclosure, and you can get that information remotely. You could prevent someone from paying for a unit that might not be there if the inventory is completely gone. And what I ended up using these individual strain gauges and essentially making kind of like a smart shelf. All right, now let's talk electronics, which I expect is why everyone's here listening to this video. For electronics, we need to answer two questions. The first being power and the second being connectivity, how the device is going to connect to the internet. After some deliberation, I ended up choosing to go forward with the particle ecosystem. The particle ecosystem allows for super easy development, and it's got solutions for everything that I need for this project. Within the particle ecosystem, I opted to use the MSOM, which stands for the Multi-Radio System on Module that Particle offers. What's nice about this, and you can see it on the upper right-hand corner here, is that it offers Wi-Fi and cellular out of the box without having to deal with SIM cards or getting too crazy with radio layout. Particle also offers a power module that allows an easy solution to some of the unique power constraints that the MSOM requires. For load cell measurement, I went with the NAU 7802 ADC, which is an I2C analog to digital converter that makes measuring the weight of the system pretty easy with well-supported software. And then I have some MOSFETs that switch the 12-volt power out to the 12-volt solenoid that we're using to lock the entire enclosure. Let's talk about the firmware for the system now. The firmware is relatively straightforward. Really, all we need to do is make sure we can unlock the device remotely. This is made really easy with Particle's cloud functions. I've also exposed another couple of operations like the tear, the calibrate, and the refresh commands. And I've got a ledger set up, which is a new Particle feature, which allows you from any sort of web application to query the current state of the device and get information like our temperature or our inventory. From my application code, I don't have to subscribe to events or make sure I'm not missing any messages. It makes it really nice and easy. And so really the main event loop is quite straightforward. I'm just grabbing information from the sensors, I'm uploading them to the ledger instance, and I'm really just waiting for if we should send an unlock signal to our solenoids. Let's talk payments now. I've patched together a number of different services to manage the payments for the system. I'm using Stripe to process and confirm the payment information from the user. It's Stripe hosted payment links. Once a payment gets confirmed, it calls a webhook to a serverless function that I've configured, hosted in AWS Lambda. That serverless function is responsible for calling the Particle API, which then makes a request to the Particle Cloud function that I defined in my firmware. I can do some fun things with Particle as well, like the ledger instance that I mentioned before. In my AWS Lambda, I can check to make sure that the inventory that I've measured in my firmware still has some, remaining jars of honey, and I can prevent any sort of payment from going through if there's no inventory left for the user to grab. And that's kind of it. That's all the pieces put together. I've got a video showing a payment being processed here. So now I'm filling out the payment information. This can be done on a computer or your phone as you're walking by. And we'll give it a second to confirm here, and Stripe process the payment, and you can see the door opened.